All right, equations and inequalities. Very similar things, one tiny nuance, and then also number lines included. So we're going to go over one-step equations, two-step equations, and inequalities, and then we're going to throw in number lines. So the one-step equations, every single time that we went through this, I asked you, what side is the variable on? You pointed. That's where you start. What operation do you see? You would say it, and then I'd say, what are you going to do? You do its opposite, then you'd rewrite the problem, and you'd have x equals. I'm going to give you two examples. Well, three, maybe four, I don't know. Let's see. So a number next to a letter means multiply. We had to review that again. I just want you to know that equal sign is always going to be the dividing line of your problem. And okay, so what side's the variable on? This side. That means we're starting there. What operation do you see? Multiplication. What's the opposite? Division. So you're going to do that to both sides. Don't skip any of these steps. Don't skip any of the writing. 2 divided by 2 is 1. So I just dropped the x down. That's 1x right there. If you count how many x's I just wrote down, there's one of them. 10 divided by 2 is 5. Okay? 2 times 5 is 10. Yay! So what is it? What about if it looks like a fraction? Well, now we're going to still do the same exact process with those questions. What side is the variable on? It's on that side. What operation do you see? Anytime you see a fraction, you know that that's going to be set up as division. So it's dividing by 2. My next question is, what would you do? You would do the opposite, which is times 2. It's best if you don't use an x to show multiplication because you're using an x as a variable. So anything that's divided by 2 and then you multiply it by 2, it'll turn it back into one whole. So this turns into 1. There's 1x. 10 times 2 is 20. So if I put x back in for x, 20 divided by 2 is 10. Check. Now let's take a look at some addition subtraction ones. Same process. You can see that the process is not changing, just the answer to the question is changing. So what side's the variable on? The left side. What operation do you see? Plus 2. What's the opposite? Minus 2. Minus 2 on both sides. Organization of work is extremely important. If you have 2 positives and 2 negatives, you get 0. You're going to drop down what's left over there is x. 5 minus 2 is 3. 3 plus 2 equals 5. Check. Okay, so let's switch it up a little bit. We're doing the same process. What side's the variable on? It's on this side. That means I'm looking for the operation on that side. What do I see? Minus 3. What are you going to do? The opposite. These are the questions you need to be asking yourself as you're moving through these. 3 negatives plus 3 positives is going to zero out. That's adding opposites. Adding opposites always equals 0. 7 plus 3 is 10. So 10 minus 3 equals 7. Check. That is 4 examples of exactly how to solve those algebraically. Now moving on to two-step equations. Not much different. The only difference is you're still doing PEMDAS backwards, so you're going to start with addition and subtraction first, and then you're going to handle multiplication division at the end. So let's go through some examples. Okay, 2x plus 1 equals 11. So same process. Okay, what side's my variable on? This one. So that's where I'm starting. Do you see any addition or subtraction? Answer is yes. I see plus 1. My question to you is, what are you going to do? I'm going to do the opposite. Minus 1. If there's anything being added or subtracted, always start with that first. Positive 1 minus 1 is 0. I'm going to drop down what I didn't use. 11 minus 1 is 10. Now look at this. We're down to a one-step equation, the things we just went over. So what side's the variable on? Still on the left side. Do you see any multiplication or division? Yes, a number next to a variable means multiply. So my question to you is, what are you going to do? I'm going to divide by 2. 2 divided by 2 is 1. There's 1x. I just wrote one of them. 10 divided by 2 is 5. If we substitute this back in for x, 2 times 5 is 10, plus 1 is 11. Check. Now let's do one more example with two-step, and then we'll jump into inequalities. All right. Same process. You can see I'm still making the dividing line along the equal sign. So always starting with addition and subtraction. Variables on this side, that's where I'm starting. Do I see any addition and subtraction? Yes, I see plus 4. Well, what are you going to do? Minus 4. Positive 4, take away 4, you got 0. That leaves you with x divided by 2 equals 2. Variable still on the left side, check. What operation do you see? I see a fraction, so that means division. My question to you is, what are you going to do? I'm going to multiply by 2. Again, avoid using x to show multiplication. All right, so let's plug this back in. 4 divided by 2 is 2, plus 4 is 6. Check. Now, whenever we get into inequalities, the only thing that you have to double check is whenever you get to this point. It's exactly like what we just did, but pay attention to the signs of the numbers. If you're multiplying or dividing by a negative, the sign flips. So let's go over a non-example of it flipping and go over an example of it flipping. Okay. Wait, hold on. Inequality. All right, so that's going to be less than or equal to. That works for me. All right, so the same process. You're going to see the process is exactly the same. That's still my dividing line. Do I see any addition or subtraction? What side's the variable on? Over here. There it is. That's why I'm identifying that I have adding and I have multiplication. So we always start with addition and subtraction. Minus 1. 0 pair. Drop this down. Now we're back to a one-step equation. Don't forget to carry down your inequality symbol. You see any multiplication or division? Of course I do, because I see negative 2 is being multiplied by x. I know that a number next to a variable or a number next to a letter means multiply. So my question to you is, what are you going to do? I'm going to divide by negative 2. And there's your red flag. Multiplying or dividing by a negative, you're going to flip the sign. So negative 2 fits into negative 2 one time. There's x. Flip the sign because I divided by a negative. 10 divided by negative 2, negative 5. X is greater than or equal to negative 5. I'm going to go ahead and skip to the next slide and write that down. Okay. I'm going to go ahead and do a non-example of flipping the sign, which is going to be almost the same exact problem, so you can just see the difference. So the dividing line, of course, showing us what we need to do to both sides. You can see that the variable is still on that side. In order to start with plus 1, we're going to get rid of it by subtracting 1. We're working backwards. 0 pair, dropping that down. 2x equals 10. And this is where I ask you again, variables on the left side. What does the number next to a letter mean? It means multiply. So what are you going to do? Divide. 2 divided by 2 is 1. There's your 1x. 10 divided by 2 is 5. So turn these into the inequality. We did not divide by a negative, so it remains that way. Notice how these are opposite of each other. I'm going to go to plot these now. So whenever it comes to plotting, we know that we have greater numbers over here, and we know we have less numbers over here. The reason that we have less numbers is because when we go this way, we get negatives. When we go this way, we get positives. If you want to just be able to use a number line or read a number line to come up with an inequality like x is greater than or equal to -5 or x is less than or equal to 5, this would be a great way to do it. You need to practice this constantly. So whenever we have a closed circle, that will go with our equal to's. Whenever we have an open circle, you would say that would mean it's not included, or it does not have the little line underneath it saying it could be equal to it. So both of these are equal to, so they're both going to have a closed circle. I'm going to plot this one first. X. X is going to be any number that's greater than or equal to -5. My first question to you is always, tell me a number that's greater than -5. You would say -4, -3, -2, -1. And then you'd be inclined to write them over here. All we have to do is plot -5 on the correct side of 0. There's -5. X is greater than all of those, all of -5. So any number that's greater than -5 is going to fit on the line. So we know that we have equal to, so that's going to be a solid dot. So we're going to color it in, solid dot. And then we know that all numbers greater than -5. So we know that greater numbers go to the right. There you go. And that can go all the way across. It's just, I didn't feel like doing it. So let's go ahead and take a look at x is less than or equal to 5. So if you just plot 5 on the correct side, you know that's going to be equal to, so that means we're going to color it in. And then we know that x is less than or equal to. We know that less than is going to the left. Less is left. So now you need to practice reading and writing these. You need to create them. Come up with them over and over. Solve the equation. Plot it. Here's how easy it is to make a number line for you to plot your answer when you get done with solving an inequality. Boom. There you go. Let's say you have x is greater than 3. Plot 3 where it goes. X is greater than 3. It's going to be open because it's not equal to it. And it's greater. That's all you got to be able to do, man.